Hi, this is Joris and we are doing another episode of 3D Printing News Unpeeled with 3dprint.com. So, we're trying to give you a succinct, impactful overview of the news, the day's top 3D printing stories. So, what are we going to be talking about today? We've found a couple of stories from very different areas, I think, that we're going to be looking at. And yeah, so let's get started. We've got 5 stories for you today. And the fifth one is kind of, I don't know what to think of this one actually. It's on the one part, it's hilarious, and then it's also kind of very tragic. But it is something important. This concerns an article that Vanessa did for 3dprint.com, and it's essentially 3D printing guns for profit. So what happened is a Houston area man, uh, as reported by Fox 26 News, um, he sold 3D printed guns to make money off of them, and he sold them to the police. So what happened was the police were having a gun buyback program, which they do periodically all over the world. They do this to get people to buy to bring guns in to get them off of the street. The idea is that that would reduce crime because there's less guns about. And what they did is they gave people $50 per gun, and this guy turned in 62 3D printed guns. And he said each one of them cost him $3 to make. So he was actually making money on turning in the 3D printed guns. And a part of this is really funny, and it's also really sad. And then the one thing that I think is really relevant for us to know is this really exemplifies a gulf between making a shape, which we're good at. We're good at making like most shapes, let's say, and making a functional working thing. And that gulf in understanding between what we know is that there's a big difference between being able to make a certain shape and being able to make a functioning shape. That's just huge in the eyes of the media and the eyes of the people. And I keep telling people, if I told you I'm a glass blower and I can blow glasses and things out of glass, and you asked me to make a bumper for your car, we both know that's not going to work. Now, if you would give me enough money and enough time, could I make a bumper for a car with glass? I think so eventually. But it's going to be like a lot more expensive and a lot more difficult than just using it polymer or other technology. It's the same thing with the 3D printed guns thing. But then for some reason, if I tell you that the thing is made out of glass, everybody will understand that that's not going to work as a bumper. But for some reason, with any kind of new technology, this kind of like, yeah, people automatically assume the thing will be functional. So I think this is another example of that. And this guy was, went on to make over $3,000 on these 3D printed guns, or $3 million in revenue, let's say. So the other thing, story number 4, is helping the net zero transition. So this comes to us from CanadianManufacturing.com. And it's an article about Burloak Technologies, and it's about, the idea is it's about lightweighting, but it's saying like, we lightweight parts of cars and we make longer range electric cars. We lightweight parts for industrial equipment, and we're helping the net zero transition, right? Um, and we say this, right? We say, there are environmental benefits to the process, right? Which are not, by the way, always true. But, we're able to lightweight things, and that has environmental benefits. But I don't think we really kind of have investigated this more thoroughly and really made that, into a well-staged kind of claim of saying, you know what, we can make the world lighter and we can make the world better. And that is a way in which 3D printing will help. So I thought this is a really good example of that, this article. And Yevgeny Briff, who's the business development manager at Burlock Technologies, he said, among the many benefits of additive manufacturing, our customers appreciate that this emerging manufacturing process supports their environmental sustainability goals by significantly reducing material waste and overall carbon emissions. Again, is it fluff? Partially it's fluff, but partially it could also be real if we count, if we take into account all the energy used and all the things there. There could be some real benefits there. And there definitely will be benefits if you make a part a kilo lighter. It's a kilo on the car for thousands and thousands and thousands of miles. So there's definite benefits there. So I think that's something we should really like. There's an arrow we should use in our quiver, really, and we should really look at this and see how we can how we can make this better, and how we can use this and make this more believable and true. So the third story of today. is Bosch Products buys a platypus. So there's an Australian construction 3D printing company called Luyten or something is Luyten, and they are selling the Platypus X2 3D printer. Essentially, it's a gantry, a mobile gantry with a printer on it, and that is then fed from a concrete mixer. An Australian-based company, and again, we're very skeptical in 3D printing construction. Generally, much more skeptical than we are on almost any other area of our market because there are so many lies being told in that segment. Uh, but I like this because it's refreshingly ambitious in a very limited way. We're not building all the houses of the future or solving a housing crisis or something. No, we're going to make a real product and we're going to make lots of them. So what the Bosch Products people say is that if they look at planter boxes, so literally there's a planter box, it's like a box where you put earth in and you put some plants in it, or a retaining wall, which is kind of like the same thing but much bigger. It involves an order time of 4 to 6 weeks for them to get all the materials they need. Sounds excessive, but hey, they're in Australia. Maybe that's longer or something like that, or maybe there's some problems nowadays. Now they build then the supporting structure. They make the mold, they pour the concrete mix into it, and they wait for it to dry. Now, they said the whole process with traditional manufacturing takes 10 days, including all the drying and stuff. Now, using the Platypus X2, we're able to print the planter box in 20 to 30 minutes. We've cut time, resource, and cost up to 95%. We're now literally able to manufacture at a rate that is hundreds of times higher at a fraction of the cost. And that's according to Michael Bosch, who's the CEO of Bosch Products. Um, Furthermore, he says that they're able to provide their clients with an unlimited amount of designs and variations. Now, I love that they're making something really simple and really accessible that's still, and then in a way that'll save them money, right? Now, the next bit, well, on one part, they say that they're using Luyten's proprietary concrete mix, and this is 6 to 8 times stronger than regular concrete, which I'm more skeptical about, let's say. And I would love to hear more about this. and and but the next thing is what really caught my attention. So they want to start a new factory, and they hope that they can then make 1 million planter boxes a year with extra capacity. Now, I don't know if this is possible. I don't know what the market for planter boxes is in Australia and globally, and I don't know if like day to day this would actually work. But if it does, this is a hugely exciting, a hugely impactful thing. Then planter boxes could be one of the top 10 3D printed products in the world if this comes true. But it does show us, I mean, and what I like about it, I don't know what's going to come true of this, but what I do like is that it's not focused on some crazy geometry house thing where we're making one house and at questionable economics, and then we're just going to say that's $20,000. Well, it isn't $20,000; it's actually much more. But what they're doing is they're making a fairly straightforward product, and it would seem to be that it's much cheaper and potentially even faster. So I really like that, and I think there could be many more outdoor furniture type of outdoor advertising and outdoor kind of garden type of things that you could 3D print. I'm quite excited about that. Now, the number 2 story is 3D Systems buying DP Polar. Now, this is probably the story you talked about if you weren't talking about the Stratasys and Covestra story. DP Polar, what is it? It's a very exciting technology. It's a ZAR printhead, and then there's a segmented, rotating, circular build platform. The printhead stays stationary, and the build platform rotates underneath it. Now, this is a brilliant idea, right? And I think everyone that saw the DP Polar thing at a show or trade show or something, it's one of these like stopping your tracks moments, and it's one of these moments like, wow, why did no one think of this earlier, right? So it rotates underneath the printhead. We could put serially different printheads in place with different materials if we wanted to. We can inkjet different materials onto this thing. Think about like we make like a polymer material, then we inkjet on top of it. We inkjet a conductive material, and then we inkjet on top of that a different material, right? We could also, on a different part of our little circle, place a pick and place machine that'll add in some kind of electronic component, a chip or something. So it seems like this is a really well-suited architecture for mass production. Perhaps much simpler anyway than I think than a lot of this InkBit, for example, is much simpler in architecture than Figure 4 is, and all these other kind of, we call them the racetrack type of systems. So that's very interesting that now 3D Systems has this. right? And the ability of this system to jet multiple materials and get multiple different properties, like a flexible part and then a conductive part or something, is also, I think, could be very impactful. 3D Systems says of the acquisition that it'll help them really achieve mass manufacturing. I think they have maybe a case already, or somebody already ready to go for this, or they have already clients for this, or they already have an application. Because otherwise, it seems like a bit of an impulse buy. I don't know if companies can impulse buy things like people can, but it seems a little bit like that. Polar itself didn't really have a lot of traction. It was one of these things where everyone is really positive about it and no one really buys it, or not very many people buy it. It was also backed by Altana, a large German materials company. And they sold out of this, so not participating in the future thing. So maybe it didn't really achieve what Altana wanted it to achieve. Or, and this is another sign of the materials companies backing away from our market, not finding it very interesting anymore. Now, what we don't know is, does this mean that 3D Systems is going to be moving away from Figure 4? Is this going to replace Figure 4? Or is this going to be, like, for electronics manufacturing, we're going to use Polar, and Figure 4 we're using for other stuff? I don't know. We don't know. But it's a very good talk about move. I don't know what 3D Systems is going to do with it. I don't know how they're going to deploy it, but it definitely, from an IP standpoint, this is a very nice buy by them. Now, the number one news item. This is the one that I saw. We saw this on 3D Printing Media, by the way. And the ZAR article, or the 3D Systems DB Polar article we did on 3dprint.com. The other one, the Boss Products article, was also on 3D Printing Media, by the way. The Net Zero Transition was in Canadian Manufacturing, and the Guns for Profit guy was also on 3dprint.com. Just to tell you. But this next article was also on 3D Printing Media. Now, it's a number one article, and it's a number one article because it's potentially huge. The most impactful thing you didn't read about yesterday, you should have, or today. And it's one of the 3D printing startups I'm most excited about. And I'm really excited about what other people can do with the same technology as well. So what it is Bella Sano is entering into its first clinical trial of 10 patients with pectus excavatum, which is a congenital chest wall deformity. And what they're going to do is they're going to put in them reabsorbable breast implant scaffolds. These are porous polycaprolactone. Polycaprolactone is a very safe material that's very that's reabsorbable into the body. I am a huge fan of polycaprolactone. It's my favorite 3D printing material, and I'm very fascinated about all the things you can do with it, because you can stretch it, you can harden it. It's very, very strong, very flexible, very soft. I think it's an amazing material. So that's already great, I think, because think about it. We now have breast implants that are in a polymer. They're supposed to stay in the body for the entire duration of the breast implant. That's, of course, not an ideal situation. Now we have something that reabsorbs. So that's already wonderful. Now, what then they've done with this, it's even more ingenious than you thought it was. What they do is they make a relatively small incision, and then they do a folded up, kind of compressed version of this scaffold. They put it inside the breast, and then it unfolds inside of it. Right, so the incision is smaller, which means that cosmetically that could be better. That could help patients heal faster. That could help make the procedure more popular because it's less painful. And then it unfolds inside the breast. Right, now that's already a very positive thing as well. But what they then do is they take liposuction and take fat from the own body, put it inside and on top of this scaffold. And then within 5 years, the scaffold is reabsorbed into the body, and the fat tissue from the liposuction remains. So this, if it works, and they're a fair bit of ways along, but they'll take them a lot more investment and time to get there. If it works, this could be a completely new, far safer, far better way of doing breast implants. The breast itself could be better / more natural, right? But at the same time, it could be much, much safer to put this in the patient and have this a long time in the patient, because the material is reabsorbable. And later on, even this reabsorbable material will go away, and just the body's own tissue will remain. So this could be a absolutely huge procedure, and can really wipe the floor with all existing breast implant procedures. That's one very exciting thing they're doing. Again, this is one clinical trial, They're going to do one for 10 patients. Later on, they would want to do one with 20 patients who are having a breast implant revision surgery for congenital breast defects. So it's going to take a while for them to get this to market properly, but it's very encouraging. Now, on top of that, think about what other implants you could have across the body with polycaprolactone. Imagine doing kind of like a facelift type of implant where the implant is reabsorbed, and then the effects of the facelift kind of wear off after a couple of years, right? Then you can get a new procedure done, or you can get a different one with your new face, as you grow older. You wouldn't just be looking like you're scared or you don't, you just hit a deer all of a sudden for the rest of your life, right? So that kind of stuff. Imagine like a nose implant. There's a Korean company that is doing this as well with nose implants that are made out of polycarpolactone. And you can get much wider shapes of nose and do procedures that you can't do because you're just not only taking away, you're going to add a nose as well. So that to me is hugely impactful. Hugely impactful on elective surgery beyond the breast implants, but also in lots and lots of other applications. So that was our news for today. These are the 5 stories. I'm going to put the links in below the article in a bit. So thank you for listening. Share this with other people, and thanks for your time today.